So what I'm presenting today, you may be fearing, oh no, somebody trying to put an LLM on things. It may be a topic today. I don't want to hurt anybody's feelings, but it's an exploration of two things. One is the good side of LLMs, which I believe is useful to incorporate into our software, and the other one is an idea on user experience that is not a chat thing. So the idea of Glue Data right now is, I call it a data browser. The data part is because it's not about text input, text output, which is the usual thing you think about when you think about an LLM. And also it's the default way of create. That's why chat is the thing. You enter text, you get text, you write more text, you get more text. But I'm more interested in data and structured data in general. And like knowledge work, which usually like some part is text, but most of the other parts are basically interpreting and working with data. And merging those two, trying to get away from the text in, text out and chat interface, I landed in another abstraction, which already exists and people know, which is the browser. And the idea of adapting the browser to LLMs and data is that basically you have like an address bar, but in the address bar, in the browser, you can write either a URL or a search query. Here you write like a prompt query. So let's say I want to see like debt to GDP ratio from Kennedy to Obama. I basically send that and it's sent to an LLM. And what the LLM does is it's basically Glue Data is a plugin platform. It searches through the components registers for the one that matches the best. And it extracts from the prompt the arguments and pre-configures the component. So basically this component is to show economic data from an API, has different metrics, time series, and you can specify like from and to. Basically, it got the series from the prompt, and it got the start and to from a really fussy natural language expression. So, or you can say something like GDP from Italy World Cup to Brazil World Cup. It's pretty Latin American centric prompt, but here what it says is, okay, I can show you two different ones for some reason. Oh, because there are two Italy World Cups. That's interesting. So I can select one and it will basically get that one. And this is kind of the URL of the component. Is a structured thing, basically like an ID plus some arguments. And it identifies the thing. It works also as a title, but you can like change it then and manipulate the things to your liking, and it will update. So that's the thing. Where I'm kind of breaking away a little bit from browsers is that I present data in a like tiled based layout. So as I load more things, I basically pick a tile layout that works best for the amount of components you're looking. I try to present all the data, not scroll. I have a long story with scrolling things. So I'm trying to get away from that. And also because you get basically a dashboard by default or something you can look at and share by default. And so let's look at other things. Let's say I want to do a task list for a camping trip. Just to show like here a little bit more of the generation of things, but also the components. So I have a to-do list component that can do whatever like to-do lists can do, but it's pre-populated by the LLM with all the tasks and whatever. So as you can see, it basically auto layouts. As you add more components and you can create more sessions. But let's do something more. Well, the economic data is interesting, but let's do something more future of calling centric. You can interrupt me, of course. So I maintain the history and search and things from future of calling. So I basically dumped into a SQLite database the chat history, and I created a plugin with some components. So I can say Slack message count by channel. and it's going to show me messages by channel. And here, if it's also the idea of components, where each component is not generic, it knows about the domain. So if I click here in the Thinking Together channel in 2020, June something, basically that click has a domain meaning, and it will say, okay, you clicked on a channel in a date. I can search for messages for that channel in that date around the date where you clicked, so 1 month before and 1 month after. So it basically carries the context of the things you've been doing. So I can search for that, and it's going to show me messages for that channel around the date. And something I think I haven't mentioned is the idea of smart links. I extend the idea of links. Links on browsers are like all have one type, which is the type link, and they all point to one resource. The idea here is that links have types. So whenever I click on a link, I know of what type it is and what data it has. So other components can say, I know how to display myself if somebody comes from a link of this type with this data. And here I have the obvious ones. I took this style from like Notion and Airtable, like the nice pastel background thing. But there are others here, like the user and the channel here are also smart links. So if I click on a user, it tells me, okay, for a Slack user, I know how to display the message count by month for that user, or I can search messages in a date range for that user. So if I click on the message count by month, for that user, it's telling me, okay, this user in this date range was speaking these channels, like the amount of messages. And that's the idea of a plugin. A plugin registers components that can display data for that domain, but it also registers types of smart links and also registers which components can react to smart links, either from that plugin or from others. Let's see one case for that. If I say map of Milan, it's going to hopefully show a map of Milan. And that's like Google Maps, but this link has like its allocation, but it has also geolocation. So any other component can say, hey, I know how to handle things that have geolocation. So I can make a route plan, I can see the date and time, and I can see a weather forecast. So
speaking of time, I am going to call time on the demo, Mariano.
Okay.
But we still have 7.5 minutes of question time. So if anybody right off the bat has a question they'd like to ask, just unmute yourself and ask away.
Yeah,
go ahead.
I guess I'll start. So what does it look like to build one of these components? I guess that's the one thing I wonder.
What it takes to? Okay.
Yeah.
So each plugin is a folder with 1, 2, or 3 files right now. It can be one if the plugins are only UI that interacts with some external API or no API. It's just a file called UI.js, and it has to export at least a function called setup. And you get basically things you can get out of the argument, which are like kind of dependency injection things. And so I extract some modules, libraries, functions I'm going to use. This, like, it's just mapping like weather code to icons. It's not important. Here I'm registering a component. A component has a name. It's by default namespaced to the folder it's in, so you can clash names because they are namespaced. It can have fields. Nothing fancy, just like static methods. There are some static methods that are expected. So whenever the LLM wants to create an instance of this component, it's going to call this function. A component can be registered to multiple like LLM things. So it will, like, the LLM will call me with the one he picked. I use this in some places where you can return different things depending on what the LLM is calling you with. And the arguments is like the arguments that the LLM extracted from the prompt. So in here, I extract the place, and if it's not provided, I just default to Istanbul. And the makefn is the thing that, let's see, where am I? this thing at the top, it's like the query thing, like you set the arguments there. Handle context action 4 is like if you register yourself as a component that can react to the user click it in smart links, it will call this function with the value it was clicked, and you return an instance of yourself. So basically, so that you configure contextually to the thing that was clicked. If you're reacting to only one thing, it's pretty easy. This is serialization metadata, like which fields are going to be serialized and what kind of serialization. Like the default is fields, which is like the serialization framework. And the other one is JSON fields, which is like just do JSON, that's stringify, it's raw data. Then event handling, you can react to 3 things: to UI events when the user clicks or whatever, effects, logic events with like init, resume, like life cycle stuff, and effects, which is like if you request something to the server or to another component, you get called back with the result of the effect there. And this is just like accessors are used in the UI, more like view kind of computed properties. Then CSS style, it's scoped with the latest CSS scoping things. And so the CSS you write here only applies to your component. You don't have to like do like by hand name spacing with long names. And the view is HTML. It's a template thing I created with like loop and similar to Vue.js in a sense. So this is a component. Basically, it's like 200 lines of code. And then you register the component, and then you expose some metadata so that the LLM can like find you and like pick you and call you with the right things, which basically is, okay, this function, this is the factory class, and this is the title, this is the description, this is the schema of the like, because the LLM sees you as a function it can call, like, or a tool. So you say, I have these fields, it has the fields have these types, and the types have these descriptions. This is how the UI renders the function thing. And this is I registered saying I can, if somebody clicks on a geolocation or a geolocation with a particular type, I know how to handle them. Like you can list me as somebody that handles those. And then you can list examples of prompts you should be able to handle. So that's for examples in the UI, but also for the prompt, for the context in the prompt. So this is just here, like basically a lot of that, the metadata is used here to provide examples. Like, well, yeah, so I have plugins that can do more LLM things, like extract the information from a page or summarize the page and stuff like that. So it's you create a folder. Sorry,
I'm going to butt in here and say, since this is just the first question, and we've got about 2 minutes left, if anybody has a second question, it might be good to get that in. If anybody else has a thing they'd like to ask Mariana.
Which LLM are you using?
Right now, for demos, I use ChatGPT 3.5 Turbo because it's fast, so I don't have to wait. But it also works with Mistral 7B because I explore for some of our customers, they don't want to use ChatGPT, so they want to host something local or run something. So it works with Mistral 7B, and it should work with Llama 3. It needs to support what's called function calling or tools, which is not text in, text out, but you basically send some JSON with this JSON schema, and it can pick one tool from there and tell you, I would like to call this one. And not all of the open source models support it, but like small ones like Mistral 7B, which is a small one, it can even run in a laptop, and it's good enough.
I've noticed that there is a raise hand feature in Zoom, and Conrad has raised his hand. So Conrad, what is your question?
Thanks. Well, it's a mixture between comment and question. This looks for me very similar to Wolfram Alpha. Actually, I use Wolfram Alpha a lot like this, like kind of natural language queries with data being returned. So I wonder if you compared the performance, the quality of results, the way it works, because Wolfram Alpha is way older than LLMs.
I never use Wolfram Alpha. I only use, is it I think I've used it. This is the the one you can search.
Yeah, it's alpha.wolframbot.com.
Oh
It's
yeah,
the
I
website,
use it. I use it a lot for when I want to see like some like statistics, economic data, stuff like that, or population. It may have improved in the last couple of months, but before LLMs, I use it a lot for economic data, and it doesn't always understand what you're asking for. And also like the charts are not, they, at least for the kind of data I use, they are pretty limited. The thing is, it's weird because El Mathematica is pretty advanced, but yeah, one of the ideas behind this is it's not only basically provide that capability to like any company that wants to have that Wolfram Alpha, but for internal stuff, but also because I was pretty annoyed at Wolfram Alpha not understanding some of my queries, basically.
Cool. That is time. So thank you, Mariana. If anybody else has questions, feel free to post them in the Slack thread that we've got going for this meetup. And yeah, that was super cool. I had a question, but there's no time for that, so I'll ask it to you in Slack, and we'll carry on that conversation. Great. And yeah, the hand raising thing, that's a great idea. So when we get to, you know, if there's a presentation and somebody wants to ask a question in the middle and you don't feel comfortable interrupting or whatever, feel free to do the hand raise. How do you do the hand raise in Zoom?
In the toolbar below, there's a reactions icon. And if you press that, then you can raise your hand.
Great,
like
cool. Right, nice.
You can also drop it again.
Cool. Okay, yeah, let's make use of that. That's a nice augmentation. Michael, who's up next?
Cole Lawrence.
Cole Lawrence, cool. And Cole, are you good with the 7.5 minute split?
Yeah, I think it's
cool.
Perfect. I might try to end early.
Nice. Yep. And feel free to start whenever you're ready.
Hi everyone. I'm working on a browser extension that allows you to search a bunch of different private sources. We're currently in like a dev page so that it's a little bit faster, but essentially I can like search somebody's name and get sort of a overview of a bunch of different like calendar events, Gmail, and web browsing that I might have done with someone. Then what we can do from here is potentially even summarize something. So if I were to take an article, I think LinkedIn has a broken scrape at the moment, but we'll get a feeling for the AI tooling that we're building, even if the stuff's jank. So
Microsoft has issues today. Some things are down. Like many things inside Microsoft are down. So maybe just in case something doesn't work.
Okay. Yeah. Well, the scrape is done while you're browsing. So a unique characteristic of this Chrome extension is every single thing is completely local. We don't have any user data, or no user data actually goes through our servers aside from a single OAuth handoff. So we have like a stateless OAuth handoff that then puts the access tokens and refresh tokens directly into the secure storage on the Chrome extension. And then everything happens in the background. So that limits some of the stuff we could do, and it's one of the reasons that we opted to build a lot of tooling for ourselves as opposed to use others. So what's happening here is I can take an item and summarize it, and this is going through multiple stages. So what's happening is I have these prompts, a bunch of different prompts. We have like an expert prompt and a summary of the activity lists, and then all messages. There's also like a piece of knowledge, which is the activity list itself. And that gets fed into the summary. The summary gets fed into like the expert prompt. And then the expert prompt is used for both follow-up question suggestions and continued convo. So it's kind of like this DAG in a way that, but it allows you to incrementally build it up. So if I were to look at like the execution for summarizing that record right there, what we'll see is each prompt but filled out. So one of my favorite prompts, the reason I actually did this whole exploration was because I was really passionate about exploring this "you are the activity expert" prompt. So this gives you the activity list summary, and basically prompts you to say, hey, please describe me as an expert in these topics. The output of the "you are activity expert" then is, let's go to where it is. Activity for example, like, and continue the conversation here. Oh wait, that would be, we have to ask. And we'll look at that. That might be the right one. We go to our
Kartik
continue.
just raised his hand. Kartik, do you want to ask your question?
Go for it.
Sorry, I just lost the thread somewhere in this because it sounded like at the start you had a browser plugin which allows you to scan your local data. I don't quite follow the jump from there to the prompts that you're talking about.
So the context, when you have all of the local data somebody has like available, our goal is to build sort of like a generalized RAG. Like, or basically if you ask, when was the last time I met with Sullivan, then we should do query expansion, look up with parameters like your Google Calendar, their LinkedIn profile, and then put that into a context, and then ask make a prompt to help fill out like an answer or prepare for a meeting.
Related to that question, the things on the left are kind of skills that you teach the tool, writing like semi-structured like text instructions, right? That's it's kind of a scripting, natural language scripting thing.
Yeah, except it's deterministic. So on the left side, there's no like tools, and it doesn't choose the tool. It's like,
is there a local LLM here?
Not at the moment. This is using,
okay.
Everything's backed by OpenAI.
Totally custom. Okay, cool.
Yeah. When browsers ship with an LLM embedded, which is on the horizon, like probably a year or 2 years from now, then we will use that. But right now it has to be OpenAI since you don't install anything, and we don't process user data. But you can provide your own OpenAI key. So this is like a good example of what I'm describing is there's a text that's "you are the activity expert." The output of that prompt was "you are an expert in finance with a strong background in investment management." And we're using that as a system prompt. So it's almost like we're doing this flip that's not possible with most AI prompt editors, because that activity expert is saying, describe me as an expert, the user. So then we take the output of that assistant to say, hey, this is how much you're an expert of this, which is a better prompt than like describe yourself. Describing yourself is not something an LLM does very well. So through this kind of system of back and forth, we can craft really interesting and intricate sort of prompt setups that are adapted to the exact context that you're in. So like we can kind of tune like a bunch of free prompts as a part of the prompt, but it's still very deterministic.
So you said it's not like tools, so it doesn't pick. So how do you decide which ones run or don't run?
It's mostly wired up manually in the actual like code. So there's like a specific thing that asks evaluate follow-up questions. And when it says evaluate follow-up questions, it's going to provide a bunch of like knowledge to that spot. So we create like an editable context. That AI root is actually built with its own like knowledge. So anywhere you can say like dot, like add placeholders. And then this would be like author name. And then you can like put a value kind of thing. And then in the actual prompt, I'm not going to say that because it won't work. You could like basically say author name like that. So there's a lot of manual wiring that is in the background. We've only made it customizable at this point to basically author all these prompts. And so each one of these manual prompts becomes its own piece of knowledge that can be injected into the editor prompt. And that's kind of the end user programming side of this.
So the user can edit the things on the left. Add or
I would say not our end user, because our end user is not a tool maker, but us as a team.
okay. Also,
and
this
our
is a
prompt engineer.
Okay. So the end user just uses those prompts that are pre-available. Okay.
Yeah, there may
But
be a
you can
feature where
customize
we
them.
allow them.
You can customize them for different objectives or different people with different jobs or
Yeah.
something.
Our theory is that our platform will grow to more than 100 separate prompts, depending on very specific contexts. So preparing for a meeting with an investor is a separate set of prompts from prepare the right recipe to cook tonight. So we're trying to optimize for, let's make it as easy as damn possible to create bespoke like prompts that lay into each other for every single use case that could come across. And then, if someone's like, oh, I want to use fourth thing for, as I mentioned, like choosing the right recipe from my browsing history, we can just whip together, in maybe a day, a set of prompts that does that really well. So that's our goal, is to get to a point where maintaining hundreds of separate prompts is manageable.
Have you tried to customize it for software development for your work?
No, not yet.
No.
But yeah, not yet, because it's too far away from the actual editor.
Yeah, and also probably your first customers are not going to be developers. I don't know.
No. But
We're running a bit low on discussion time, so I think we should let Cole do a bit more demo, and then if there's questions at the end, we can burn the last minute and a bit of discussion time on that.
the questions are really helpful, but I'll show one more demo. So first I just showed summarizing a record. In the meantime, we have this feature that we're building called the timeline. So it basically looks at all of your browsing history and tries to like categorize it into little groups. So this is where this actually is kind of interesting, is we could say open a specific activity and that loads all of those items into context. Now, what it's done is it's going to try to, oops, I guess where I added that really janky thing is probably broken. Say like this way. So there's a series of separate, also smaller tasks. It will summarize each record in this list to create a smaller version of them, and those happen in parallel. So like the record summary does that. So it's like, but what kind of outputs is sort of the end result of all these little pieces. So if we say to continue the conversation, we load that. we can kind of see the full context of what actually happened. Why did this answer come? Why is this the answer? And so we can say, okay, well, the whole prompt here is, hi, I'm Cole, which is that username, and I am activity title, exploring WebP vulnerability and solutions, which I'll share below. It looks like it kept this certainly part, but here's a summary of the content shared. This came from a separate prompt called the activity list summary. And we can see how it tried to summarize those. We can show long text because there's a lot more here. It's the sort of summary for each thing. Can I turn off Grammarly? This Grammarly is kind of bothering us. Is that okay? Yeah. Encoding, blah, 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 each one. And then there's our activity expert. Here's system, you are an expert. This is another thing that I really wanted, was always to like put the system prompt, like reorder the system prompts from the prompts. Because I have this theory that LLMs do poorly when you start a prompt that has like a directive, like do the planning and then take the plan and execute it. I feel like there's like these jags in different directions. That's like, okay, first I need you to go this direction, and then I'm going to redirect you to go this direction as you build up this conversation. That's the thing I wanted to avoid the most, is I want every single prompt to be an exact direction, like with all the exact context. And so every prompt should kind of feel like it's a linear, like there's one goal, and then whatever comes out of that goal is used to the next prompt. So it has one goal.
We're right about at the end of time. Do you have any final 30-second summary words or anything like that, Cole?
No, that's all.
Cool. One other question I had, and I'm going to pause the clock very briefly, and then I'll ask my question, and then we might even go back to Mariano in a minute for this. But one thing I'm noticing, and I think this relates to Kartik's question earlier, is it would be super helpful to know for each of these presentations we're hearing today, what is the like scope or the context of the thing that we're demoing. So is this like a project you're doing at work? Is it something you're building as a personal project? Who are the users? So is it something you're building for yourself? Is it an internal tool for your team? Is it meant to be customer facing? And sort of just do a little bit more setup of like, why does this tool exist and what is it for? And so that way, as we're seeing these features, we can kind of imagine how it fits in with, you know, is this an internal detail that we're interested in as engineers? And we're going to be thinking about like, oh yeah, cool, that's a neat implementation detail, or that's a nice way of solving that problem. Or is this more user-facing stuff where we look at and think, that's a way, you know, you're surfacing the information and I can imagine myself as a user using the tool rather than as a developer relating to it about, you know, how might I borrow these ideas in my own work, solving my own problems. So that, I think for the last little bit of the question time, Cole, I'd love to hear you just very briefly say, like, here's the scope or the context of this thing that you're building.
Yeah, so this is our internal AI editor, which would be used primarily by our prompt engineers. It's currently a team of 2 people, including myself. So both of us are the prompt engineers, but it's about giving that prompt engineering role as much control and understanding for what the LLM is doing as possible, and giving them enough flexibility to experiment and avoid this jagged issue that I've mentioned, or a bit theoretical, but yeah.
So if I understand it correctly, there's this browser-based tool that is for searching either your own local personal data on your own computer, or maybe your company's internal data, you know, that this is the tool that your end customers would be using. Yeah. And then the LLM editing interface, that sort of text markup language you've got with the different prompts, is for you and your partner to be using internally to develop this browser tool.
Exactly.
Cool. Yep. That really helps kind of, you know, make compartments for all of the things that we just saw you demoing and help us understand how they fit together. So thank you.
Hey, Ivan, is there a specific channel in the Slack that we want to use to post follow-up questions?
If we wanted to do it in present company, that probably wouldn't be a bad idea. Or you could do it in the thread for this.
I could
meetup.
I could make a post and share your work.
Yep, that would be great
have a
too.
thread
Yeah.
there.
Okay, let's do one thread per demo.
Great idea. Cool. Yep. I love the thought that I would have all the answers to these sorts of questions, but no, I just, you know, mop the floors and leave it up to you all to make the most of the space. So yes, good stuff on yeah, one thread per demo. And just before we proceed to the next one, Mariano, I'm going to throw 30 seconds on the clock to give you a chance to do a bit of context setting for the demo you shared, if you want to say anything more about that.
Yeah, so initially it started as an exploration on basically, can I create like free-floating components and basically have a platform where I can just register and have them all in one place. The initial exploration was a tool for me, like model development to create components. But over time, I started liking it and thinking, like, can I make this my main work? And I thought about basically, can I use this as a platform I can use to implement internal tools and visualization stuff for customers? So I would like people to use it personally. The plugin works and you can use it. It's not documented, but also the idea is that organizations and teams can use them to do work with it. Basically, it's like a moldable development environment for data stuff. Pretty generic.
Cool. Michael, who is our next presenter?
Declan, if I pronounce it correctly.
Yep, that's Declan, that's fine. So pleasure to meet you all. You can hear me all right, yeah?
Yes, though you might have, if you're wearing headphones that have a mic on them, you might be using you might have Zoom set to a different microphone because we're hearing quite a bit of room echo. You might want to see if Zoom is on the right mic.
Is this better?
It will be okay. Pick whichever mic you feel like is closest to your mouth.
Is this better? No.
Actually, maybe slightly. It's a little more present. You'll have to say some things though for us to actually know as you're making changes.
Okay. How about now? Any better? Worse?
I think maybe the earlier one was better.
Right.
Yeah, sorry about that. Should I share my
this
screen
is good. Yeah, sure. Go for
it. So context then. Calclang is a project I'm developing myself. It's my own interest and trying to see, interested in feedback really on where it sits amongst other things about what it's related to, calculations. And it'll take us a few minutes to get to the demo, but first of all, thanks for joining me to find Calclang. So on Calclang website, calclang.dev, we have these interactive models. Some are finance related, calculators and loan calculators and graphs, and down here some interactive simulations. One is a 3D world you can move around in, rendered to a bar chart. One is a climate model where you can draw a path to zero emissions and see a calculation for temperature. So from this, it might look like Calclang is a thing for interactive models, but that's not what it is. And behind these, I have some tools and API to help to directly map formulas to visualizations. So that might make it look like Calclang is to directly visualize models and formulas, but that's not really what Calclang is. And at Boston in February, I gave a talk, and one of my main focuses was about a direct connection between formulas and workings. There's an example where we can click on numbers coming out of the savings calculator, and we can double click on a number, and we see an overlay of the workings on top of formula code, which we can navigate. So 5308, 5204, 5204 is this plus this, 82.43. So I might give people the impression that Calclang is about a direct connection between formulas and workings. But it's not. In the same talk, I showed this piece of paper, imaginary, where you're asked to pay back 12,329 euros every year for 10 years based on some sums. And with this QR code, I can connect this number to the world to 12,329 through the QR code brings you here to the workings, which you can navigate as before and see the workings behind this calculation. But these things aren't Calclang, and Calclang is a language for calculations. It's concerned with structure and clarity and things that are convenient to connect numbers, workings, formulas, to visualize numbers, to interact with them, and to communicate and share them. So finally, we found Calclang, and in this talk, I want to take it close to the metal with Calclang today. But first, the aims of this language for calculations. And the aims are to be shareable, communicable, transparent, verifiable, understandable, concise, and flexible and reusable. And we get a lot of these things for free, just through being a language for calculations, which prompts a separation of concerns. So it prompts you to take your calculation logic and separate it from your programming logic, general programming logic. And when you do that, your calculation logic, your calculations will be more shareable and will be more communicable, and it will be more transparent. And because we're dealing with pure calculations, it will be more verifiable. And since you've taken general programming out of there, and then your calculation logic will be more understandable, and for the same reason, more concise. So just due to having a language for calculations and forcing the separation of concerns, we get a lot of these things for free.
I'm gonna jump in here and ask a question before we keep going. So this tool you're showing us, it's an environment for doing sort of complex series of calculations. You know, we can infer that from using it for the climate example, getting to net zero, or the loan calculator, that sort of thing. How much of this, as you're designing and building out this tool, how much are you thinking about, this is going to serve as a tool that somebody would use instead of a spreadsheet, or this is a tool that somebody would use instead of one of those sort of text-based calculating tools like Solver or Calca or some of those, if you've seen those. I'm sort of wondering, like, where does this tool fit in the sort of space of other calculating tools?
A third category, explorable explanations.
Yep.
So, yeah, okay, sorry, I missed something when I was talking about context. Right now, the things I show you here, they're definitely targeting developers. It is like a programming language. Now, it's something where I have some, environments on top of it, some user interfaces that are more user-friendly. That's an area that I'm experimenting with, playing with. But there's really two things. So Calclang itself isn't opinionated about how it's used. So we can do lots of experiments about user interface and all of that. But so I'm not really targeting users at the moment, apart from the output. So the output, the models that are produced are JavaScript, which I design my own user interfaces for each different model. That's the interactions I show in calculating.dev. But that's really something that I must do separately to using the calculator to get that model.
Cool.
So,
yeah, that answers the question. Yeah, that helps me imagine who's going to be using this, and the QR code I think is good because that shows like part of this is about not just doing a calculation for your own personal, like I have a question about numbers and I need to answer it, but also I'm producing a model and I want to share that model with other people so that I'm like communicating through a system. I take it that's part of the goal here as well.
Yeah. So the goal really, yeah. So there's the scope really is where numbers are used, and then in theory, can we have like a language that can describe numbers, and then we can have multiple different tools to interact with and understand them. Some that are user friendly and some that are more for developers and changing. So many of these aims we hit for free, just through separating the different logic. And the last one, flexibility, reusability. This is where some new concepts come in. I put that in quotes because I'm interested in feedback about this. Input inference and modularity. And we'll see some of these. We'll see how this works in the demo. But these two things complement each other. The purpose is to make formulas which are flexible and reusable. So continuing on about what showing you Calculang, what it is, then I have this environment to try to surface to developers what Calculang is doing. So this is showing Calculang that we write here, and its output, which is here, and the output, the key output is this JavaScript module. So Calculang piggybacks off JavaScript, and your output is a JavaScript module with no runtime and no dependencies, just an ESM JavaScript module, which is portable, and so it can be, you can put it on your blog and make UI or use numbers from this model on your blog, or it could be embedded in a news article that you're reading, or in theory in academic papers or in your banking portal. But to try to understand what the Calculang compiler does, this is what I want to focus on. And here in pink is highlighting exactly what the Calculang compiler is changing. So what we're seeing it doing here is called input inference. So there are only two new primitives in Calculang: formulas, which are implemented like functions in JavaScript, and inputs, which are also implemented like functions in JavaScript, but have this convention.
I'll also, I've been meaning to do this, 1 minute warning. Okay.
The Calculang compiler determines how inputs are used, and infers how to populate all these brackets for all these function calls. So that's what input inference is doing here. And therefore, when we need to change something, say units or say price, and these prices are fixed, our model has now become independent, and we can see that flow all the way through. If we need to implement a demand curve, units is no longer an input. It depends on sales price, and the whole model reflects that. Then this demand curve, because of flexibility and flexibility and modularity, we can implement it in a different way. This is an example down here of the same thing implemented using those features. We have the same original formulas, and we get the exact same output here, but rather than come in and copy this or change this directly, we're importing it into a separate module and we're changing or overriding one of the formulas. So in this way, we're able to basically ask for, I want this number, but I want to override how this thing is calculated. So that's an example of flexibility in Calculang.
And that is
So-
time. So yes, questions, great. Nicely done. Oh, though, Declan, actually, did you request extra time? You wanted 10 minutes, if I remember correctly.
I did, yeah.
Yeah.
There isn't a lot more that I could go through. I could go a little bit deeper, but I think if I take questions at this, it's
Yeah, it's likely we'll get into some of that in that way.
I have a kind of question to know if I understood correctly. Can I do that?
Yeah, go for it.
So you're kind of transpiling, I imagine, a subset of JavaScript where you define like sequence of formulas where parts of the formulas are other terms, and you basically rewire them. You transpile it so that you find the dependencies and you inject them in the places where they are required, something like that, right? And that gives you some kind of interactivity, or I guess.
How do you mean by that? Sorry.
So the idea is that the end user, me, I write formulas like saying this is equal to this other term plus this other term, and this other term is equal to this over this other, and you basically parse that and you find all the relationships and you compile it to JavaScript by basically injecting as arguments the things that each formula needs. And I can imagine that gives you you can do interactivity, or like you can change the value and see how everything changes or something like that.
True. Yeah. So there's two ways to interactively get an output from Calculang. So what I'm showing you here is Calculang compiling it in like real time, basically.
Mhm.
Now that's not really that's really convenient to demo Calculang compiler, but the interactivity, say in the models I show here, is not using the compiler. It's just using this. So you get this module, which is like a static module, but it has all these dependencies which you can call in different ways. So effectively, really what this is giving you, Calculang overall, is a kind of concise and, in my opinion, more general way to write formulas, and kind of more meaningful way to write formulas. And you're getting this pure functional output, which you can make interactive,
So if I use the module that's generated and I call one of those functions passing a value, it kind of propagates that value to
propagates it downwards.
all the places where it's used.
Yeah.
Okay.
We've got a tiny bit of question time left. So very briefly, this seems like the calculation language and the compiler that you've built is designed for like a one-directional flow of calculation. I'm curious if you've had thoughts about doing bi-directional calculations, or doing things where you can scrub something on the output side and see that come back on the input side at all.
Okay. Yeah, it's very interesting. So there's one really nice way to do that, which is like symbolic manipulation, reverse the thing, like get an analytical solution, I think. Another way to do it is, which I haven't done anything but symbolic manipulation. Another way would be like goal seek, or use some numerical methods to get you back. I played with that for one example a long time ago, and it is a very interesting one, but effectively what I was building was goal seeks here, goal seeking formulas to get you back. So nothing very elaborate or convenient, but yeah, it is one directional effectively. You
Cool.
can go the other way with a little bit of work.
Mm-hmm. Yeah, very cool. Thank you for sharing that. We have one more demo today. Michael, is that you? Is that you doing the final demo?
Yeah, that's me. Exactly.
Nice. All right. Let me just get the clock reset. And I should be asking, you're good with the 50-50 split questions and demo time? That works for you?
Oh yeah, that's fine.
Cool, great.
Let's see, I'll start sharing my screen.
Yeah.
So
let's see, Declan, can you stop your share?
I think you already did because I shared my screen.
Oh, I have it set so multiple people can share.
Ah, okay.
Yeah, but there we go. Yep, we see CodeFlow Canvas IO, and whenever you're ready, take it away.
Yeah. Yes, I'm Michael. I'm a freelance software developer from the Netherlands, and the demo that I'm going to give is about my side project, which is a visual programming system, which on top you can build other visual programming systems or languages. And it's actually a subsidized side project, which means that I get some kind of I don't get money from our government, but they give me a subsidy. I don't know how you say it in English exactly, but which comes in the form of a tax deduction. So that way I can spend a big amount of time on it every week, that's very nice. I'm going to show two parts of what I'm building. Which is the first is the more flow-based programming-inspired system, which I built on top of my system. I can add very simple nodes. There's currently various ways how you can add them. Either via this drop-down or via this toolbar. I can put a number in there or a command in there. Do some simple calculation. Program it executes, and you see the data flowing. And you can also play it back, so you can debug what is going on in time. Or you can put it on full speed, in which the program runs immediately. Currently, it's still very basic. There's I have some examples, but you cannot build currently a full program with it. But that's my intention, that I would be able to use this in my own job, for example. But currently, it's not. There's not enough features yet to be able to do that. This is a Celsius to Fahrenheit converter, for example, which works bidirectional. If I put the speed a bit lower, then you can see the program actually executes. And how this works, basically, it sends, when I type something in here, it sends data to the connected nodes, which perform some action. There are nodes which can store variables, data in variables. So you can also define variables like you can do in a regular program environment. And these variables can be observed and trigger other flows again. But that's part one of what I've built. I've also got a different kind of flow, which looks completely different. That's the graphical language part. With this, you can actually build very simple shaders. And to show a small example, this is the standard shader from ShaderToy. I don't know if anybody knows that here, probably. But this works different than the other than the engine that I just showed. that the engine that I just showed works forward, but this one actually works backward. So it starts with when generating the shader that's behind this, it starts with the output color node and works its way backward to generate shader code, which then gets executed over here.
A quick question, a difference between this GL version of the CodeFlow canvas and the previous version is that this one, the code graph that you've defined is being run every frame on every pixel. Is that correct?
Yeah, exactly. Yeah.
Yeah. So is there a way to see that same sort of debug view where you can explore a specific evaluation through time on this one?
Yeah, well, that was one of the things that I was thinking of. How can I solve that problem? Because in this case, for every pixel, this is executed. So that's, yeah, I thought that's very hard, but I tried something, but which I will show you now. One of the features that I recently built was that I'm able to change a node, which to a node that's compatible. For example, this multiply node, this arctang node is compatible with it. If I change it, then you see that the program changes. And just to show what I want to show, I changed these positions. What I can do with this slider below, I can walk through the different versions of the flow that I created. So when you see, then at least this might give you some feeling of what the impact was of a change that you made. What happens under the hood is that for every change that you make in the editor, the compilation of the shader was correctly, then it's stored in a timeline, and in that timeline you can navigate to your timeline with this slider on the bottom. But I'm not sure myself yet how useful this is actually. It's not the same as yeah, with the other flow, with this, that you can yeah, that you can really grab the program counter, so to speak. That you can, it's different.
Mariano
so
has a question.
Yeah.
Feel free to jump in.
Yeah.
Yeah. Well, maybe you can give a short answer now and later if you want, right, in the Slack conversation. But I would love to hear your strong opinions on the current state of nodes and wires. What do you like, what you don't like, what you want to try that's different, and that's the long. Maybe you want to write it in Slack, but a shorter one is how do you see yourself using it? Like for logic, for wiring UIs? Do you have an idea of a use case you would like to reach in the short term?
Yeah. Let's say there's hope questions. In the short version of where I see the state of node and wire programming, something that I can really irritate myself when I'm actually using this to build something, because it takes a lot of time. Programming in text is way faster currently, in my opinion, than at least than with my own interface. So I'm trying to look for solutions to speed that up. And one of the things was to be able to change this node, instead of deleting it, dragging and putting a new node on the canvas and reconnecting everything. I wanted a way to immediately change the node type to something that's compatible, to see what the impact is of that change. So I think to be competitive with textual programming, visual programming environments really need to be very smart and effective, more effective than textual programming environments. I think that's still a big challenge. At least that's so far what I've seen.
Question from John Christensen.
Yeah.
Yeah,
Right.
curious, how much difficulty do you have with like creating a graph that's too computationally like expensive? I don't in either one. Does it like ever, just like, I don't know, you accidentally create something that is just really too complicated and it kind of is like surprising, or is it like it's always, because it's constrained with how big you can get something, it doesn't really ever explode in complexity too much?
Yeah, well, I have ways to, let's see, if I understand your question correctly. For example, I have this this Mandelbrot graph. There's this. This is of course, the main calculation for a fractal Mandelbrot, but there's a lot more going on. This is actually a composition of other nodes, and that helps to to put more complexity, not in the main graph, but deeper in the system to manage the complexity. And I think those kind of things are also really needed to prevent that this becomes one big a lot of spaghetti, if that makes sense. Does that answer your question?
Yeah, I think that helps. I guess I'm also curious, just like, do you ever run into performance like bottlenecks of creating a shader as you're just kind of like doing it, or is it always like fast enough that your GPU just takes it?
Yeah, well, I'm probably not good enough of a shader coder to get into that limit. But this is also running in the browser, so there are obvious limits, but I've not come across them yet. But that's probably because I'm not the best shader coder. If I look what
I mean, that sounds like you're a great
demos,
shader coder. If you don't hit the limits, you're doing great.
yeah, well, if I look at the demos from 3GS, for example, yeah, that's of course very different environment, also different kind of shaders, also the fragment shader.
I have a question about the, you showed the composition showing the formula for the fractal, and it was a nice example of both a downside and potentially an upside of doing math in a NodeWire environment, which is, it's annoying, I think, to a lot of people to have to put every single operator in a node and wire it up one at a time. Like, that's one of the frequently cited frustrations of NodeWire. But there is a nice thing here, which is that it's a sort of a formula that takes these three inputs. One of them is a constant, and then the other two are coming in from outside, and it sort of creates this little network of the calculation, and you can sort of see how that calculation is structured in a very differently interesting way. And I'm curious if you have other examples like this that you found. Oh, the nodes view is actually potentially a nice way to look at a certain algorithm compared to text.
Let's see, maybe.
And feel free to disagree. I don't want to like put words in your mouth and say like, oh yeah, that's good. If you actually hate that and would prefer it written in text,
no,
that would also be interesting to hear.
Well, there are two parts. I actually agree that, yeah, it's sometimes difficult to read what is going on in a flow. Sometimes, yeah, actually having an expression in text is easier to follow than this, I think. So I think definitely these kind of environments also need a way to enter a bigger expression in a text field. In this environment, I have that a bit more. Let's see. For example, that's still a very simple expression, but I have this expression node, and in that you can enter bigger expressions, not just limited to the simple addition, but you can also use brackets or parentheses. Those kind of things can be much more complex. So I definitely think that you need those things in a visual programming environment, not just.
And is that doing a relative offset, like array comprehension sort of thing?
Yeah, that's exactly this. When you execute the program multiple times, this run iteration is the times that I pressed at the start of the program.
Right, 0, 1, and then
yeah, exactly.
Interesting.
And this references this node, and -1, that's that one, -2 is that one. So every time you execute. The nice thing about this version of the editor is that you can understand some algorithms a bit better. This is quicksort. Still, if you look at this from a high level, it's probably still hard to understand what is going on. But this helped me to really understand quicksort, actually. This graph is created when this program executes. You can also walk through it, and then it starts with this as input, and quicksort works with a pivot point. In this case, it's always the first item of an array. Everything that's smaller gets put to the left, and everything that's bigger gets put to the right. That's
very cool. We are at time.
Yeah, I was afraid of it.
Yeah.
Well, that presentation was really cool.
What? Excuse me.
Sorry, say again, Kartik?
I was just saying that final visualization of the pivots was really cool. I just wanted to call that out.
Oh, thank you.
Yeah, that's our meetup. Thank everybody. Thanks for coming, and thank you to Cole and Mariano and Michael and Declan for the demos. That was, fun to see what everybody's working on and what overlap and what differences there are. I think we've already got a date lined up for the next one of these in about a month. So yeah, that's perhaps the next time we'll all see each other is in that environment. Yeah.
Anybody have time for like hallway conversation?
Yeah, if people want to stick around and chat, great, let's do it. But if anybody's got stuff to get on with their day, by all means, just drop whenever you feel the mood.
I'll stay on for a couple of minutes.
Yeah, I'll stick around for a bit.
Can I rejoin?
Rejoin. Yeah, rejoin. I'm not sure what you mean.
I have an extra question for Michael, if I can.
Yeah.
What's the semantics or computation model of the graph? Is it mutable? Is it immutable? Is it like FRP? What is it?
Well, the shader part is purely a compilation. It compiles to a GPU shader, which gets executed with WebGL context. The other one, yeah, it's more. I think it's more or less. It's not only immutable. The data that you send from one node to the other, that's immutable, but you can also store data in variables which are mutable. In the past, I've also had a different version of this of a visual programmer environment where I sent a payload object through the graph, and that payload object was every time cloned, which was that was immutable, because I ran into problems when I didn't do that.
And you can observe the change of variables that others set. Is there any way to avoid like infinite loops or like I don't know, infinite recursion or whatever?
Yeah, that you can probably cause all kinds of problems currently. I try to have solutions for that when possible. But with that Celsius to Fahrenheit converter, there was some construct in there to prevent infinite loops, because both flows, both text fields reference each other. Actually, it are loops, but when there's some kind of check in it. I can't really explain it now, but there's some kind of check that if a node was already executed, then it stops. That's basically the idea behind that.
I have a question for everybody who presented today, though I think Cole took off already, which is, and I guess we can kind of go in order. Do you, and I'll ask you this, I'll direct this question at you, Mariano, but then maybe Michael and Declan, you can answer as well. How do you define success for your project? Like, what is the goal of the thing you're trying to build? Is there a specific end destination in mind? Is this just a process that you are going through? How do you decide, like, you know, what you're working towards?
The initial exploration was, I was creating it for myself, but I noticed something that I've seen, read, or talked multiple times, which is we talk a lot about like end user development and stuff like that, but I couldn't find enough things I wanted to automate or build components for, other than the ones I have, like weather, time zones, maps, currency conversion, like statistics about countries and stuff like that. I ran out of personal things to automate. So my initial one was that, like something I would use at least a couple of times a week. But I ran out of problems I had that I could use it for. I use it for some of the things, but the current one is I want to implement at least one proof of concept for somebody to use it in their day-to-day work. And I started already. It's a logistic company. It's the space I found where it works is ad hoc exploration of data, something that it's too custom sometimes to put in software, but it's too ad hoc to put into dashboards. Something that you look up every now and then, some numbers, you want to see a table, something you will probably would like to have a button somewhere that is export to Excel, that kind of stuff. But you can see like in a chart or in a map if it makes sense. So yeah, my current definition of success is implement a proof of concept where somebody or a team uses it for something, cool. Whatever that means.
How about you, Declan?
So short-term goal for success is like Calclang having its own life, at least with some community around it. And in some of the things that it's capable of that now, things like education, someone mentioned explorables earlier, those kind of things. But its own community, there's other people using it, getting use out of it. But the longer, wilder success or part of the motivation is the numbers, you know, in the world and in papers in science, reproducibility and all of that can be explained through Calclang. And even when I started programming from the beginning, I've always wondered about things, like curiosity, like all of us, I'm sure. And the magic behind a lot of things, like you understand how a computer works, and then you discover handwriting recognition, and it's like magic. It's maths. So that's kind of a part of my drive to, in all cases, when I go digging, even if the source code is there, there's too much to untangle. So the wild version of success is to untangle maths, and in the computers, we can answer questions about them without this entanglement.
Cool. How about you, Michael? What does success look like for you?
Well, a small success would be that I have a positive contribution to visual programming to help that go forward. I'm actually very much inspired by your own project. Really, I loved your podcast on Nest. A bigger dream is that I'm coming at a point where others can use my tool and that I can work on this full time.
Nice.
And it doesn't even have to be my own tool, but yeah.
And I saw Cole, you rejoined. If you're in the position to do so, I'm asking each of the people who presented what their definition of success for their project is. If you wanted to jump in and share that.
Sure. What do you think would be more interesting, the definition of success for the investment into the internal tool or the product more broadly?
Maybe both briefly. I think the former is probably more interesting to this audience, but I'm personally also curious about the second one because I, have to exist in society.
So the very short thing of the broader product is I call it the cure to context switching. So can we read your calendar and summarize everything relevant to it before you even enter, and then record work activity. And this is contingent on the idea that the majority of the workforce will be entirely in the browser. So if you're doing Coda, you're doing Google Docs, you're doing Google Calendar, you're doing Microsoft, all in a browser. So unlike coding, this actually may scale really well for somebody who the majority of their work is looking at web pages. Then for this internal tool, the definition of success is, I think, already achieved because we can visualize something that had been very tricky. So my co-founder is less technical and doesn't touch the code. He reads it deeply and answers tons of questions about historical knowledge for why things are set up, but he's not writing and engineering. So to enable him to be an effective prompt engineer is a real big thing for me, to ensure that if he can adjust things and digest lots of research articles about different ways to do prompting and then actually test them with this real data, which is really hard to get out of the platform. It's hard to copy paste 90 separate little record items that are Google Calendar events and browser things. It's a lot easier just to work in the medium itself and do that prompt engineering. So when we start to see him being feeling more empowered to make contributions to the prompting and explore better stuff, then that's going to be a huge win personally.
Yeah, it's good to have an actual user and you can see how they're making use of their tool and learn from that and make adjustments. And I find that, at least for my own personal explorations in this space, I'm the user, and so it's hard for me to have as objective a perspective on the work that I'm doing as I would have if there was another person actually doing it. So yeah,
and we benefit from not having to. I had this conversation with Mariano at one point. We benefit from not having to prove value in first 15 minutes.
Yeah.
You don't have to make the dumbest, easiest possible tool and do all this, the other 90% of the effort of building a great UX. We just need this pro tool user to become effective. And then we just optimize for the features that actually benefit, and expand our platform.
A great thing is also when it's great to have a first user that is not you, because you can evaluate more things. It's great if you can see them use the tool, because if it's software as a service or somebody downloads it somewhere and uses it and reports feedback, you never see them use it. So they may not tell you something they are doing, or they may be using it in a weird way you never thought about. So it's great that your first users are like physically, or at least they can show the screen, show the process. That's really cool. I have another question
I have a little follow-up to that. It's comes in like a very dry patch for us, because we don't know what our users are doing at all because of how our tenets of privacy work.
Right.
So we currently are in this place where we have like 100 daily users just because Chrome Web Store told us that's how many people. But we have no idea if they hit it for everything or if they're using it dedicatedly. So I don't know. That's a
Just
I
want to
have
say I have to go, unfortunately.
Okay.
Yep. Thanks for organizing.
Thanks.
Yeah, you're welcome. Thanks for coming. See you next time.
See you.
A nice day or evening.
Yeah, me too.
Bye-bye. Bye.
Yep.
Volker coming, and see you next time. Was very nice. Thanks, everybody.
Yeah. Thanks, Conrad.
Bye.
Thanks, Conrad.
Cool. I have one question. If anybody has, I can wait. Okay. So can you tell me about? Yeah.
No, I'm saying you go ahead. That's the
Okay.
The floor is yours.
Can you explain a little bit more, like the when and how your system executes? It reacts on me saying something or clicking something. Does it do work in the background to like pre-process and index stuff? But also, like, if you said like there are kind of different actions or strategies. Does it do them a couple and then reacts, or it does them in a sequence? How does it execute, or when?
Okay, so there's two parts. There's a principle for when we actually run AI functions, and the interesting part of what we're building as a single user application. We don't have a team. It's not an enterprise tool. It's just you and your data. So we actually make a lot of choices in what I call like human time. So if you visit a web page, we will, in the moment that you're visiting that web page, probably run some AI to summarize, categorize, do things like what kinds of questions does this web page share the answers to? And then you can do like a semantic embedding of the questions that generates. But all that's going to be in real time when you're in it. So every single AI cost is going to be tied to an explicit action taken by a user at some point. No cron or anything like that. Okay, then the second part of that is, and how I would describe it, is how does it actually execute? We don't really, I think this is interesting, so I'll answer in this way, is the way that we kind of have this cache of like, if multiple prompts all share like child prompts or sub prompts, we just use runtime semantics of JavaScript to basically create like a map and say, hey, the map, this placeholder at this key was resolved to this promise. And then everybody else. So we're able to leverage like just how a normal cache would work to make sure that it all goes in sequence. There's a second part that kind of ties both those things together that's kind of interesting, where it's been a very heavy investment to make sure every single AI call is also paired with a purpose string. So every time you run an AI function, you kind of pass in, as a developer, here's the name of the feature, and here's the reason that we're running this. So every cost should actually be completely traceable to when did it run, why did it run, and what was it called, so that in a future, we can actually allow a user using their own API key to disable certain features because they may not want to pay the cost of those. Or we just want to know why. They're like, why did I pay $5 this month? Well, we know because it's this feature, this feature, this feature. So by building all the tooling ourselves, we can actually accommodate all those needs rather than taking an existing tool. Like we use this really amazing package called Dexter to do our AI process, but it doesn't support that sort of provenance and tracing out of the box. So we had to create our abstraction.